Hi, everyone. My name is Leela Karumbunathan. I'm a hardware product manager here at NVIDIA, focusing on edge AI and robotics. Can you all see my screen okay?
Yeah, we can see it.
Great. So it's been a great day about kind of a lot. You've learned a lot about the different components and where some of our partners, you can collaborate with them. And so what I'm going to focus on today is our Holoscan sensor bridge, which is a piece of our larger Holoscan story. And it's really about bridging and making it easier for you to be able to integrate sensors into your applications. There are really two big challenges that we are trying to solve with Holoscan Sensor Bridge. The first is that many applications have many sensors and many different kinds of sensors. Systems need 5 to 6 or even more. And there needs to be a way to easily both synchronize the data between the sensors as well as be able to integrate these different types of sensors and have them easily talk to your compute. The other thing is, historically, some of these things have been done leveraging PCIe or other interfaces, and the data management can be complex. Mission critical applications like robotic surgery or endoscopes need really low latency, and you need to be able to communicate between these sensors and the compute easily. And so we created Holoscan Sensor Bridge. And so what are the key benefits of Holoscan Sensor Bridge? The first is its low latency. With Sensor Bridge, you're going to be able to quickly receive real-time sensor data and process it on the GPU. So you can see in this right image here, you have your sensor. There's going to be an FPGA sensor bridge, and then the GPU compute. So the sensor type, it could be MIPI, it could be LVDS, I2C, CAN, UART, any kind of sensor, and you can bring in all of these sensors into your GPU via Ethernet. And I'll go into the architecture in more detail as I kind of go through the presentation, but wanted to kind of highlight in terms of what are the benefits and why would you use Sensor Bridge. The other key thing that is often needed for these mission critical applications is being able to easily stream into GPU memory. And so with our IGX platform that supports ConnectX, this allows you to do RDMA. And this also really reduces the latency between sensor and compute. It's a scalable architecture, so for those 5 to 6 or even more sensors, you can easily scale from 1 to many, enabling 0 to 100 gigabits per second of data. It's multimodal, so instead of having to worry about each individual sensor and doing the development of the drivers for each of those sensors, because all of these sensors are aggregated and come in via Ethernet, it makes it really streamlined. The other thing is synchronization can often be important. You were just looking at a robotic surgery example. And so in that case, you need to be able to, if you have multiple cameras or multiple different types of sensors, you need to be able to communicate between them. And so the latest version of Holoscan Sensor Bridge supports something called PTP, which is Precision Time Protocol. And I'll go into the details of what that enables. The next is that Sensor Bridge is secure and reliable, so it supports things like redundancy as well as failure detection and security protocols. So that way you can make sure that all of the data is secure between the sensor and the compute. It's plug and play with our various software components, and it's really easy to develop. The real goal of Sensor Bridge was to not only enable you to bring your own sensor and bring your own real-time sensor, but also reduce the development complexity. And so this is really what the architecture looks like. So there are kind of 3 components to the architecture. There's your sensor, there's our Holoscan Sensor Bridge, and then your compute platform. So today, Sensor Bridge is mainly supported through developer kits with our FPGA partners. But once you're ready to kind of go to production, you can work with either the sensor vendors or you can develop this where you integrate Sensor Bridge into your design itself. And so the architecture basically is that you have your different types of sensors, whether that be camera, SDI, RF, motor, LiDAR, and they come in via kind of the I/O plane. Then we have a custom HoloLink FPGA IP that handles both the control as well as the data plane. And then it packetizes all of that sensor data and sends it to either the AGX or IGX via 10 gigabit Ethernet. We are working with a number of partners that are actually integrating Sensor Bridge into their cameras or sensors themselves. You also have the ability to customize and bring your own sensor. So depending on kind of what you're looking for, you can either work with one of our sensor partners or develop and bring your own sensor. And so jumping into a little bit more details about what exactly is the Holoscan Sensor Bridge FPGA IP. So I mentioned that there's the data plane side as well as the control plane side. Those are really the two main components. The data plane is mainly for data transfer of the relevant sensor data. And what happens is it gets packetized to UDP packets. And then the control plane is the data transfer that's relevant for your host. So that way you can easily communicate between host as well as sensor. The control plane could be receiving and decoding the UDP packets from the host to access the registers that are going to be transmitting specific network protocols across the Sensor Bridge IP. The real value add of the Sensor Bridge IP is that it's open. So the IP is available for you to download from NGC. It's configurable, so you can configure the number of sensor interfaces, the host interfaces, the width of the interfaces, as well as the frequency of the interfaces. So going back to kind of the first point that I was talking about in terms of the multimodality of it and being able to leverage multiple sensors, leveraging Sensor Bridge really streamlines that. The other thing that you should think about is the control interfaces. Sometimes when you're working with different sensor types, you have to worry about the drivers for some of the lower level interfaces as well, like GPIO, I2C, SPI. The great thing about Sensor Bridge is because you're leveraging this FPGA architecture, you can now basically streamline it so all of the data comes into your compute via Ethernet. And instead, you just have to worry about the operators that you're going to call on to be able to integrate your sensors. There's also support for an APB bus for the read and write. And if you need to add more to the top level of the Holoscan Sensor Bridge FPGA IP, more customizations beyond just the data management piece, we have partners that you can work with and add more into those solutions. So as I mentioned, this is an open platform. So the RTL can be found on NGC, and the link is here. Basically, I took a screenshot so that you can see kind of what will be there when you go to the NGC link. But basically, you can download the files here, and it will download this folder repository for you. And I wanted to highlight the key files that are relevant for updating and adding your sensor operators are really the top level RTL. So the HoloLink definition file, which our documentation goes into kind of each of the different components, and then the HoloLink top. That's going to be the main place where you make updates. So some more details about the IP itself is that it's designed to be really easily configurable to various use cases, such as kind of what we were talking about, the number of sensors, Ethernet ports, and it's also compatible with multiple FPGA vendors. The IP transmits a broadcast UDP enumeration packet approximately once per second. And the content of that enumeration packet can be sourced from the onboard non-volatile memory, and it's further defined in this hololink.definition file. What happens is the IP basically transmits that UDP enumeration packet, and so that way you can have access to it and make changes to it. The Holoscan Sensor Bridge IP provides both system initialization functions to write to the registers upon power up, and the function is used inside that Ethernet block that I was talking about, so that way you don't have to worry about, oh, do I need to call on a sensor or when? You just have to basically define your operators, and everything about the Holoscan sensor bridge IP gets managed for you. Jumping into a little bit more details about the sensor bridge software itself. So the other thing that's great about sensor bridge is that from a sensor's perspective, you don't need to write kernel space drivers in order to support various sensors. It's completely user space. And so this full stack solution really ensures that the data provided at the FPGA sensor interface can easily stream to the compute. So with the IGX, you can leverage streaming DMA via that ConnectX. And then with the AGX, we support a CPU emulation that still leverages kind of the low latency aspects of sensor bridge. And so the key things about sensor bridge from a software perspective is that streaming DMA on IGX, the ability to easily access those control interfaces, GPIO, SPI, I2C, the registers, the transport abstraction layer, and the Linux sockets. We're working with a number of sensor vendors to actually integrate sensor bridge into the sensor itself. So depending on what sensor type you're looking for, you would be able to leverage that. A little bit more details about what our software is. So you've heard a lot about, and many of you are familiar with our Holoscan applications and how they're written in terms of you basically connect the output of one operator to the input of another operator. And with sensor bridge, we want to follow a basically similar architecture. So the host software is going to leverage that Holoscan framework, and that is basically going to provide an operator that receives network data generated by the sensor bridge devices. For example, you may have a ROCKY, so in the case of DMA, a receive operator, and that will provide a facility for receiving UDP messages from a sensor bridge device. And then it will be stored directly in GPU memory. For example, if you're using it with a video camera, what would happen is it would receive the data and it would appear as blocks of memory with the CSI2 Bayer layers of the image data. And so the real advantage of sensor bridge is not only it enables streaming DMA, but it also handles all of the data and control parts of sensor bridge. From an application perspective, Holoscan applications work by creating Holoscan application subclasses and overriding its configure method and using it to construct the appropriate pipelines for your applications. Sensor bridge pipelines are usually focused on acquiring the data from the sensor equipment and performing processing on that data, and then generating appropriate outputs and transmitting the output of that data to the appropriate target. So you'll see sensor bridge leverages the similar software workflows and architectures as the underlying Holoscan does as well. You'll also be able to leverage sensor objects and their APIs for configuring and monitoring specific sensors within those objects. From a host requirement perspective, you'll need to connect to either the IGX or AGX platforms, leveraging the sensor bridge like we were looking at in the previous slide. The next piece I wanted to talk about was adapting new sensors. So you can see some snippets from our documentation here on the right side, and you can see there, this is an example leveraging a camera, and a class has been created, and then there are these configurable settings. So the great thing about the Holoscan sensor bridge software and the HoloLink IP specifically is the combination of the two provide you with the tools that are necessary to control not only one sensor, but multiple sensors. And you can support new sensors by just creating APIs rather than doing extensive development. And so what are the configurable settings? It's really the 4 items that you can see here. So configure, start, stop, and configure the converter. So from a configure perspective, what does that do? It's basically a method which uses the control plane to set up the data produced by the sensor. The start is the method that the data receiver operator calls on as the system starts up. Stop basically does the opposite when the data receiver is shut down. And then the configure converter, this allows the sensor object to configure the next element of the application pipeline. So this enables you to do both multimodal as well as single sensor development. And we have a bunch of reference examples for MIPI to Ethernet. And if you have other sensor types that you're interested, we can discuss further. The other thing that I wanted to talk about was PTP. This is a new feature that we added in Holoscan Sensor Bridge version 1.1. A little bit about the architecture is seen here in this right image. But what is PTP? It's Precision Time Protocol. So in the cases where you have some of these multimodal sensor applications, there needs to be synchronization, especially if you have 5 or 6 cameras. If the images aren't synchronized, then you may receive data from one camera later than that of another. And not only do they need to be synchronized, but it also needs to be really low latency. So what happens with PTP is basically you have a camera and you have a host, the host being AGX or IGX, and you may have 5 or 6 cameras. And as long as the camera has this vSync timestamp that is connected into the sensor bridge architecture, then what will happen is the sensor bridge architecture will basically take that vSync and make sure that over a certain amount of time, there is continuous timestamping. So it will timestamp the incoming sensor data for the host processing and synchronize it across multiple boards. So for example, if you had 5 or 20 cameras, as long as the sensor had that vSync on it, you would be able to synchronize it across different sensors. The next thing I wanted to talk about are the compute platforms. So there were kind of 3 different components to the sensor bridge architecture. There was the sensors, the actual bridge, and then the compute. And so there are 2 different options that you can look at. There is our embedded Jetson platform, and then as well as our IGX enterprise platform. And the difference between the 2 are really in terms of compute requirements, form factor requirements, and software requirements. The Jetson is designed for embedded edge applications with up to 275 TOPS of performance and up to 10 gigabits of Ethernet. If you are looking at applications that need both more throughput as well as extended compute, especially for healthcare applications, we've seen that over the life cycle of an application, the compute requirements may change. And rather than having to go and redesign a new hardware, you can now have a completely designed hardware that you can just extend the compute by adding discrete GPUs. So the IGX Orin developer kit has the ability to extend the compute from the integrated GPU from 250 TOPS all the way up to 1700 TOPS of performance. The other thing is the IGX also supports ConnectX, which enables you for high bandwidth sensor streaming. So depending on kind of where your requirements in terms of the number of sensors and the amount of compute and what your workload looks like, both of these platforms can enable you to streamline your development because they are complete systems. We have an AGX Orin developer kit as well as an IGX Orin developer kit, and that's really the best way to get started. A little bit more details specifically to sensor bridge in terms of what you may expect with the IGX Orin and the AGX Orin. This is an example, and I will put a link to the chat of a video of a demo that we recently did of basically we connected 20 cameras, 4K 60 cameras up to our IGX Orin. And we measured the glass-to-glass latency, which is really essential for some of these applications, and it was as low as 21 milliseconds. It was able to leverage GPU RDMA, and that's why you'll see the glass-to-glass latency is slightly lower on the IGX compared to the AGX. Our sensor bridge architecture, because of the data and control packetization that we do, is still able to achieve extremely low latency on AGX Orin as well. In terms of the number of cameras that can be supported, it really depends on the amount of I/O that you're going to be leveraging. The IGX Orin supports ConnectX, so up to 200 gigabit of Ethernet, and the AGX Orin supports up to 10 gig. And so we've done some validation and examples showing 20 4K 60 on the IGX and a single 4K 60 on the AGX. You can also leverage other resolution cameras as well and increase the number of cameras. So for example, the AGX, you could support up to 3 1080p 60. A little bit more in terms of the roadmap. So we launched our Holoscan Sensor Bridge version 1.0 software in May, and that was really with the initial support of Holoscan Sensor Bridge. It enabled APIs for you to configure and monitor specific sensors. It's supported with both our IGX and AGX. Next, most recently in August, we released the version 1.1, and that's where we enabled the PTP and timestamping synchronization along for support for additional sensors. We also support a hardware ISP, and some of our partners have support for a soft ISP within the sensor bridge as well. We also enabled C and C++ porting. On our roadmap with version 2.x, we'll be enabling reliability and safety, which is a key for some of these applications. And so this kind of summarizes a lot of the things that I talked about today in terms of Sensor Bridge is really designed to simplify integration and enable you to bring your own sensor. It's an open platform, so you'll see in the links that you can see on the right side here, you have access to not only the Sensor Bridge software, you also have access to the FPGA IP, as well as complete documentation. Because all the kernels are user space, you can contribute to it and develop and bring new sensors. And you can really reduce the complexity of some of your designs by using this API-driven, really software-defined approach. In order to get started, you can leverage kind of our AGX and IGX Orin developer kits, along with working with our FPGA partners to leverage their dev kits. Some of our sensor partners as well are working on sensors that integrate this solution. And then this is just a double click on the various links that I was talking about.